Hi guys, today we're doing section 9.3, which is on probability. So in order for us to start, we got to talk about a couple key terms. First thing, probability is the measure of the chance of an event happening or the likelihood of an event. So it's a measure of the chance of an event happening. Or it says it's the likelihood that an event will happen. Likelihood. It's not at all how you spell that. Let's try again. Likelihood of an event. So there are two things that could happen. Either the event happens and it's a success, or the event does not happen and it is a failure. So we can say a desired outcome is called a success. It's what we want to happen. And sometimes you see that represented as P of, and then some letter or numbers or combination of both on the inside. And that's just the probability that an event occurs. So capital P for probability, E for event. So it's probability event occurs. And then the opposite is if we don't get a desired outcome, or if we get anything but the desired outcome, any other type of outcome, is what we would call a failure. It's not what we wanted, so it's called a failure. And so we see that as sometimes P of E with a line over it. That means that it doesn't happen, so it's the opposite of that. Now, these two types of events together, the probability that an event occurs and the probability that the event doesn't occur, is a total of 100%. So if we're ever talking about probability, all of my probability is between 0 and 100%. Now, when we think about percents, we're going to keep them in terms of decimal. So we're going to say that it has to be less than or equal to 1, which is 100%. Together, the probability that the event happens plus the probability that the event doesn't happen is equal to 100%. Those two things should add up. So if it's like the easiest example, we'll do a couple like simple examples I'm sure you've heard of before in terms of probability, but the most basic one is a coin toss. So if you flip a coin, what's the probability that you're going to get heads? 1 out of 2, 50%, half. And then what's the probability that you don't get a heads? Well, there's only one other option, it's tails. So it's 50%. Together, those two 50% equal 100. So you will not have outside of 100. Also, sometimes we're going to deal with this more next time, but you'll see Venn diagrams. And we can do a lot or we can do a little with Venn diagrams. So we'll just kind of see what we can get into. Okay, that was supposed to be a big square. Okay, rectangle is fine. Okay, so a Venn diagram, in terms of like a single event happening, the circle inside is going to be all of the chances that E happens, your event happens, and everything that's not in my circle is outside of the circle and it's not that same event. So this circle could be very big or very small depending on what event we're looking at and depending on how many total options there are. So we'll, again, look at more Venn diagrams later, but I just wanted to give you an example. Okay. So we're going to start by doing, I mentioned coin tosses already. The next most common example is rolling a dice. Yes, those have a finite number of options and it's pretty easy to tell some basic probability. So we will do some examples here. So my example is rolling a die. Remember, die is singular for dice. How many total options do you have if you roll a dice? What are some numbers that you could roll? You could roll 1, 2, blah, blah, all the way up to 6. Can you roll more than a 6 with one single die? No. So this, all of your options, is what we call our sample space. So our sample space is essentially all possible outcomes. It's all of your options of what could happen. Could you roll 30 with a single die? No. So 30 will never be an option. That's not even in our sample space. So our only options, our only possible outcomes come from inside of our sample space. Okay. We're going to talk about the probability of different roles that we could have, but the probability in general, again, I feel like probability is something you learn like at the beginning of every year or at the end of every year in math, and I just don't know how far or how like how much or how little you've ever learned of this. So hopefully some of this is a repeat, and if it's not, welcome. Probability is the success or like the total number of successes that we could have over the total possible numbers that we could have. So it's like what works over all of the possible answers. So we're going to do a couple examples. So the first one is going to be, what's the probability of rolling a 2? So if I say probability of rolling 2, that took me 10 years to write. So I may write P2, and that's probability of rolling a 2. So look for my shorthand. I'll try and say it as I think it and as I write it, but that's what this means. They're the same. Okay, probability of rolling a 2. How many 2s are there on the dice? There's only one side that's a 2. So I can only roll 1 2. And how many total possibilities do I have? Yes, I have 6 options. So my probability of rolling a 2 is 1 over 6. I want us to get in the habit of leaving these as fractions. If I ask for it as a decimal, I'll let you know, but most of the time I really want a fraction, okay? All right, that was one example. Let's do another one. What's the probability of rolling, I don't know, an even number? Probability of an even number. Well, my first question is, how many total even numbers are there? 2, 4, 6. Okay, there's 3 total sides that are even numbers. And how many total sides are there? 6. So it's 3 over 6. Now, the last time we could leave it because it was simplified. This time I want it more simplified. So the best answer is 1 over 2, 1/2. What if I said probability of rolling an odd? You can do a couple different things. You can work it out just like we did on number 2, or you can think about the idea that if it's not the event, the event probability of an event happening plus the probability of the event not happening adds up to 1 or 100%. In this case, everything that's not even is going to be odd. So I'm also left with 3 over 6 or a total of 1/2. So as we do more of these, you may be able to cut some steps out. But if I can't tell how you got from one step to another, we're going to have some issues. So make sure that you show enough work so I know what's going on. All right. What about the probability of rolling any number between 1 through 6? So probability of rolling 1, 2, 3, 4, 5, 6. Well, that's any side. So there's a total of 6 options that you could roll, 1 through 6. And how many total possibilities are there? 6. So I just came up with the full set, which is 1. So 1 is a legit answer. On the contrary, what if I say, well, what's the probability of, like I said earlier, of you rolling a 30? Well, how many sides have 30 on them? 0. There's no way you could roll a 30. And what's your possible number of options? 6. 0 divided by 6 is just 0. So 0 and 1 are legit options that you could have. All right, what if I ask for kind of like a set of numbers? What if I say rolling anything bigger than a 2? So what if I said Sorry, this numbering is crazy. Just deal with me. Probability of rolling a number that's bigger than 2. How many numbers could I roll that are bigger than 2? Well, I could roll 3 or 4 or 5 or 6. Those are my only options. So I have 4 options out of my total of 6 options. So I have a 2 out of 3 chances of rolling a number bigger than 2. All right, cool. So we looked at a lot of just basic probabilities if I was just rolling 1 die. Now things kind of get a little crazy if I start rolling 2 die. So I'm going to do that next to here. So if I say, example, now we're rolling 2 dice. The reason this changes the game is because I could ask different things, like what if one dice had this number, what if this dice had another number, or often I ask about the sum of what's going on with them. What's the smallest sum that I could have? I could roll a 1 and a 1, so that smallest number would be 2. And then what's the biggest sum I could roll? 6 and 6, which is 12. Now you can think of this out in your head. I generally like to do that, but some people like to list and see all of their options. So we could technically make a table. So I'm going to make one up here. I'm going to make a little table. I know some people are more visual, so I'm trying to give you as many options as possible. You don't have to do this. I'm just saying it could help. So you could, before I even look at the type of questions, I could make myself a table so I already know what all my options are. We know that for my first die, I could roll 1, 2, 3, 4, 5, or 6. Those are all my options. For my second die, I could roll also 1, 2, 3, 4, 5, 6. This table helps me add them up to see what my solution would be. So like my first row would be, if I only rolled a 1 on my first dice, what would all my options be? Or if I rolled a 1 on my second dice, what would all my options be for my first dice? Well, 1 and 1 would be 2. 1 and 2 would be 3. 1 and 3 would be 4. 4 and 1 would be 5. 5 and 1 would be 6. 6 and 1 would be 7. This time I could roll a 7 because of my sum. I'm still not going to be able to roll a 30. That was kind of a crazy example I gave you, but we could roll anything up to a 12 now. Okay, so take a second, fill in this chart. I'm going to fill in mine. Okay, now you can see that my table is all the way filled out. So if you did not stop to do yours, do it now. This helps me see all of my possible options. So I knew before that my range was from 2 to 12, but I didn't know how many times like I could get 5. You could think that through on your own, but sometimes we miss like numbers, or we don't add something correctly. So sometimes it's nice to have this chart. So I'm going to use this chart and find a couple different probabilities. So what if I ask, what's the probability of having a sum of, I don't know, 5? Well, let's go to my table. How many 5s do we see? See this whole row right there. 1, 2, 3, 4. So there's a total of 4 possible options that would be a successful outcome. How many completely possible options are there? Well, 6 times 6 is going to be 36. And if you don't trust me, you can count up all the little boxes, but I believe 36. 6 on top, 6 on the side, multiply together, a total of 36 options. So of those 36 options, only 4 work. Okay. Now we gotta simplify that. 4 over 36 is the same thing as 1 over 9. So that is my simplified fraction. Simplified probability. All right, we could also do more than one. This isn't going to be super common, but we could also do this. We'll add on to this more later. I don't know how many of these 2 we're doing today. What if I said find the probability of us getting a 9 or a 10? Well, again, we can go back to our little chart and see all of the 9s and 10s that we see. So 9, 1, 2, 3, 4, and then 10 is 3. So I have seven are successful outcomes out of 36 possible. So 7 over 36. Can you even simplify that one? Nope, that's as simple as it gets. I kind of skipped a thought step, but the options for 9 are 4 out of 36, and the options for 10 are 3 out of 36. What happens when you see an or, and again, we'll deal with this more later, you're adding up those two values. If I said and, it'd be a different story. We can't really do two and sums here. Or you just add the sums together, which is what I was mentally doing on my table. All right, so that's good start on our rolling the die or dice, depending on what our situation is. Now we're gonna do some coin tosses. Okay. So our example now is a coin toss. One coin toss is pretty basic probability. Where it gets a little bit more complicated is if I add multiple coin tosses. So if we toss a coin 2 times in a row, 3 times in a row, 20 times in a row, and we want to see what the probability of getting certain results are. Okay. So the example we're doing here is we're going to toss it 3 times in a row. And we want to know what's the probability what is the probability that exactly 2 of the tosses are tails? The reason it's important that I said exactly is I didn't say at least or at most or less than or greater than. Like I want 2 tails, period. I don't want 3 tails. I want exactly 2 tails. Okay. Probability that I have 2 tails with my 3 times. That's just kind of a given. I'm not going to write that in there. Okay. We can do it mathematically, but we can also do it kind of like a chart like we did before. This chart helps some of us who are visual learners. Let's do another chart. This time we're going to do one of those tree diagrams. So when you first toss a coin, what are your 2 options? Right, you get heads or you get tails. Okay. When you toss the coin a second time, does your heads or tails affect what's going to happen the next time? No, I don't care if you got heads last time or tails last time, you still have an equal probability of getting heads or tails no matter which one you did. And then if I have a third round, it's the exact same idea. No matter if I did heads, I could get tails next. There's no reason that I should get one or the other more likely. So it's getting kind of smushed, but just pretend it looks a little nicer. All right, so each line coming out of it has heads and tails because it's equal opportunity for getting those. Okay, so if I did my first path, heads, does that have 2 tails? Nope, that doesn't work. So that doesn't count. If I did heads, tails, does that count? Nope. Let's highlight the ones that do count. I could go heads, tails. I could go tails, heads, tails. I could go I could go, what else could I go? Oh, tails, head. Well, took me way too long. The way this is lined up is I could write like, okay, I have heads right there, but that's a lot of writing. So I know that I have 1 option here, 2, 3, 4, 5, 6, 7, 8. I have a total of 8 options, 8 possible outcomes. And of those 8, I found 3 that work with 2 tails. Heads, tails, heads, tails, heads. So 3 are successes. So if I go back to my basic concept of probability is success divided by possibilities. I would know that the probability of getting 2 tails is going to be 3 out of 8. Okay. Any thoughts or questions? No? Okay. Okay, so now that we've done an example with the coins and one with the die, we're going to do one where we have them both together. Okay, so my example, we are both going to roll a die and we're going to toss a coin. So first thing, let's think about all the possible outcomes that we could have. So what are my possible outcomes? Well, all of my outcomes are going to at least have a number and at least have a heads or tail. Let's do the dice first because the way that I'm going to make my tree diagram, it's going to get real ugly if I do heads and then tails. So I think it's prettier if I do my coin or my die first. So if I do my die, I have 6 options. 1, 2, 3, 4, 5, 6. Okay. Once I've done that, then after each die, it doesn't matter. I still am going to toss my coin, and these guys don't affect each other. That's called mutually exclusive, and I think we're going to cover that a little bit more in depth later, but they don't affect each other. So no matter what I rolled on the die, I still have the probability of getting a heads or tails on the coin. Heads or tails. All the way down. Okay. Now, once I've determined this, these are all my possible outcomes that we can have. So let's do a specific example where we find the probability that we have an even number on the dice and we flip a tails. So even and tail. I could even put it as P of E and T. I'm going to write and all the way out though, because that's the one that matters. And T. Okay. So how many options do I have? An even number and a tails? 2 tails, 4 tails, 6 tails. So that's 3 options that I have. Out of how many total do I have here? Again, I'm just going to count the final limb, I guess, of this tree because that gives me all my options. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3 over 12. I can simplify that to be 1 over 4. Now, you may not want to make a diagram every time, and that's okay. Another way we can think about this is going one at a time, okay? What's my probability by itself of doing an even number? Well, how many total even numbers are there? And how many total numbers are there? How many total possibilities are there? Good, there's 3 even numbers and there's 6 total possibilities. Okay, what about if I did my tails? What's my probability of getting a tails? Yep, 1 over 2. I think that's the best way of saying it. Only one side is tails, there are a total of 2 sides. Now, on one of these last examples, I said or right up here, and I said or is a plus sign. On the example we're looking at now, I said and. And is different. And is not a plus sign, it's its own thing. And is a multiplication sign. So we're going to multiply these 2 numbers together. We can multiply by from here 3 over 6 and 1/2. I probably, though, would have already simplified 3 over 6 to 1 over 2. And what's 1 over 2 times 1 over 2? 1 over 4. Is that the same answer I got by doing it by hand? Yep. You can do it either way in this scenario. So I wanted to show you both of those options, okay? Okay. The last example we're going to do is a few card examples because those are really, really common ones. I assume most of us know some basics about cards, but let's go over them. Am I going to have room? We'll find out, won't we? Okay. My example here is cards. So what are some things we know about cards? Okay, there are two colors, red and black. How else do we organize them? Okay, there are four suits. We have club, we have heart, we have spade, we have diamond. And then um we have number cards and we have face cards. So we've got number cards. Do you know how many number cards there are? 2, 3, 4, 5, 6, 7, 8, 9, 10. I think there are 9 number cards. And how many face cards are there? Jack, king, queen, ace. I count ace. I guess we can fight later or discuss this later if you disagree. I always thought ace was a face card, but now that I'm teaching you that, I'm second guessing myself. But for the purpose of these notes right now, I'm counting ace as a face card. So we've got numbers, we've got face cards, and then we just have all of the different types of cards. So like I could ask you like what's the probability of finding like a 2 in the deck, or finding a queen, or finding a 7 and a jack, like all of the different types slash I don't know what a better word of that is, so we'll leave it as types. Okay. We know there's a total of 52 cards in a deck. So that means half of those are red and half of those are black. So there's 26 of each of those. And then if we take 52 and divide that by 4, the 4 different suits, there's 13 of each of those. And then each specific type or face or number, there's 4 of those. One that's club, one that's spades, blah, blah, blah. So these are not numbers that you have to memorize. They're numbers that you should know, or numbers that like you may be using, okay? If I ask you anything about pulling a card from a deck, assume that it's shuffled. I won't always write, it is a well shuffled deck. Just know that it's shuffled. Know that not all the colors are together, not all the numbers are together. It's shuffled, okay? So let's do a couple examples. So let's find the probability of finding a 5 in the deck. So if I were to draw any card in the deck, you got a shuffled deck, you hold it in front of me, what's the probability that I draw a 5? Well, how many 5s are there in the deck? There are 4, right? A club 5, a spade 5, a diamond 5, a heart 5. 4. And how many total cards are there in the deck? 52. So 4 out of 52 is the probability I'm going to draw a 5. Well, let's simplify that. That becomes 1 over 13. That's the best answer. Okay, that's not bad. What about if I say, what's the probability that we're going to draw a heart? Well, how many hearts are in the deck? If I go back over here, I know there's 13 of each suit. So I'm going to say there are 13 hearts in the deck. And how many total cards in the deck are there? 52. So 13 over 52, I'm going to reduce that. I know that that's 1 over 4. If you don't know, feel free to use your calculator. I do want all your answers in fractions, though. Don't give me any decimals. That's nonsense. All right, so that's just like one specific number or one specific suit. I could also ask for a specific card. I could say, all right, find me the probability of me pulling out a black ace. Okay. How many aces are there in the deck? Well, there are 4, right? But how many of those aces are black? Only 2. Only 2 black aces of my 52 cards, so 1 in 26. Okay, I think that's all the practice that we're going to do today. I have a worksheet that's going to be online. The book problems aren't as good as I would like them to be, and we're going to have to finish up 9-3 the next time I talk to you guys, because we did not do independent or dependent events. I think this is a good place to stop for today. So if you have any questions, let me know. Do the homework or even look in your book if you want some more examples, and have a great rest of your day.